Okay. So in this video, we are going to talk about capitalization of interest. It is a short video, just to emphasize the concept. So you should be able to learn this really quickly. So what is it? Capitalization of interest and negative amortization occur when the payment made is less than the interest on the loan. Now remember that our payment is what? Payment is sum of interest due plus principal amount. Now, principal amount is the one we use to pay off the loan. So if payment is less than interest due, what's going to happen? Outstanding loan balance is going to grow. Okay, this one is going to grow. So that's what this means. Okay, capitalization of interest. Since you are not paying the interest due, then the interest will be added to the outstanding balance. So outstanding balance is going to grow. This is called as negative amortization. Such an increase in balance is called negative amortization because the amount of principal amortized is negative. So you can see that here, if IT is bigger than payment, what's going to happen? Then the payment size would be payment minus IT, which is going to be negative since interest due is bigger than the payment we are making. Okay. So when we try to do the new balance, is what? Usually we use this rule. But now this one is negative. Okay. So since you have another negative sign in front of this one, become what? This one would be bigger than the original outstanding balance. Okay. Because you have negative time negative, it becomes plus. For example, let's say your payment is 200 and interest due is 300, and then that means what? Then your principal payment would be payment minus IT, which is 200 minus 300, which is negative 100. Now suppose your current your previous outstanding balance is $2,000, and the new one, the method is basically BT minus PT, which is going to be 2,000 minus 100, that is 2,100. So it's bigger than the previous loan balance. So that's why it's called the negative amortization. Since the principal amount amortized is negative. Okay. So this is what happened when you pay less than interest due. So basically, unpaid interest is turned into capital when it is added to the balance of the loan. So you are really adding the unpaid interest. So this 100 is what? This is basically the unpaid interest. Okay. Because you're supposed to pay 300 to cover the interest, but you are making 200. So that's unpaid interest. So you are not paying $100 from the interest due. So that added to the current balance. So new balance becomes 2,100. So here's an example. A borrower would like to borrow 30,000 at 8% for 5 years, but would like to pay only 2,000 for the first 2 years and then catch up with the higher payment for the final 3 years. What is the payment for the final 3 years? So let's draw the timeline to understand what's happening. And the balance, I mean, the initial balance is 30,000. And the rate we are using is 8%. Okay. So at the end of the year one, what is the interest due? That would be 2,400, no? So, but would like to pay only 2,000. So the payment is 2,000. So that means basically new balance at this point would be what? The old balance plus the remaining unpaid interest. So what's the unpaid interest? is you're supposed to pay $2,400, but you are making only $2,000 payment. So basically 400. Now that 400 need to add to the original loan balance. So the new balance would be 30,400. Okay. So then the interest due at the end of the year 2 time 0.08. Let's use our calculator. That would be 2,132. And in the unpaid interest, so you are making only 2,000. That would be 432. Now that need to be added to the gain loan balance. So new loan balance would be 30,400 plus 432, which is going to be 30,832. So the balance. So I need to say this is after payment. Yeah. So this is B2 is 30,832. So here you are making a payment of 2,000. Remember what does the B2 mean? B2 mean the after payment 2. Okay. So after making all the payment, what's the balance after 2 years? Okay. So now we want to pay the rest using within 3 years. Okay. So that means B2 equals. So here I'm going to make a payment. Here I'm going to make a payment. Here I'm going to make a payment. So basically payment A3 because it's only 3 years and at the rate of 8%. Okay, so what would be the payment size? So B2, we know the value, which is 30,832. I can actually use if I want the formula. So what is VV is 1.08 to the power negative 1. Let me use a formula just for change instead of calculator. So when I use the formula 30,832 time I 0.08 divide by 1 minus 1.08 to the power negative 3. So I get 11,036. So payment is 11,000. You can use your calculator, okay? I just did this one. How do you do this in the calculator? You have present value 30,832. Future value is 0. Payment what you need. N is 3. I over Y is 8%. C over Y, P over Y is 1. And you are looking for payment. Okay. You can use that your calculator, but I used the formula. So this one asks another question. A loan of 100,000 has payment at the end of each month for 12 years. For the first 6 years, the payment are Z each month. And for the final 6 years, payment are 2C each month. Interest is 12% nominal compound monthly. Find the outstanding loan balance at the end of the first year. So so right away you can see that you need to find out the payment size. So let's draw the timeline and see what this means. So here is 0, here is 1. Payments are each month for 12 years. So it's 12 times 12. N is going to be how many payments? 144. Okay. For the first 6 years, so that means 12 times 6, which is 72. The payments are Z. So you have Z, C, C. Then the final 6 years, so this is plus 6 year, and the final 6 years 2Z. Each month. Interest is 12% nominal compound monthly. So I12 is 12%. Then the effective rate per month is I12 divided by 12. This is for annual nominal rate. So 12% divided by 12, which is 1%. Find the outstanding loan balance at the end of the first year. So we want to know the B1. And the B0 is given. B0 is 100,000. Okay. So basically, if you look at this, present value for all of these cash flow need to be equal to 100,000 at time 0. So 100,000 equal what? Z time V. In here, V mean actually 1.01 to the power negative 1. Okay, this V. Okay. Z time V square all the way up to Z time V 72. Then 2C. Okay. Because you have 2C time V to the 73 all the way up to 2C time V to the 144. You can apply formula, or you can just calculate the value for this part separately and this part separately and add the value. For example, in here I can see if I take the ZV out, I get 1 plus V plus all the way up to V to the 71. And then for this part, if I take the 2Z V73 out, I would get 1 plus all the way up to V71. Okay. So now, so I have ZV, and I can calculate this, and this is equal to 1 minus V to 72, or 1 minus V. I have 2Z V73, and then again this one is 1 minus V72 over 1 minus V. So I can calculate this value. Okay, so let's calculate that. So V is 1.01 to negative 1. Okay, so let's calculate that part. 1.01 to the negative 72. 1 minus that divided by 1 minus 1.01 to the negative 1. So I get 51. So this would be ZV 51.66. Let me leave it 2. This one is 2Z V73. And then here I have 51.662. So if I take the Z as common factor, and again use the values given, what do I get? So here I get 51.15039. Plus. So this one I get 2 times 1.01 to the power negative 73 times so this one I get 49.973531, and I add those two. And here I get 101.1239. So this side I have 100,000. And I can solve for Z. And Z is 988.8856. Check this answer again. I may have make mistakes, so make sure you check it again. Okay. So once you get Z, then we want to calculate the outstanding loan balance at the end of the first year. So what is the interest due? I1 is B0 time rate, which is 1%. Okay, so you are calculating interest for month. So would be Oh, outside loan balance at the end of the first year, not first month. Oh, we had to be careful. So that would be 12. So here, so you want to calculate B12. So what would be the outstanding loan balance at the end of the first year? End of the first year. So let's calculate the outstanding loan balance at the end of the first month. One approach would be actually we can use two approach. Okay, let's use retrospective since we know the original loan balance. So if I use retrospective approach, B12 is going to be what? B12 is going to be B0. The present value of that loan amount. So you have to bring it to here. So you are multiplying 1.01 to 12 minus the present value of all these Z payment. So Z, how many are there? There are 12. Under what rate? Basically, you can use 1%. Z value is B0 So from here you can get the balance. So this one is 100,000. Z is we found is 988.8856. And S12 you can use your calculator. For example, for this one, what you can do, you can enter the payment as 988.88 and as 12. Payment per year is 1. Compounding per year is 1 because we are using 1%. Okay. Otherwise, if you enter 12%, you have to say payment per year is 12, compounding per year is 12. Then you have rate is 1%. Then you have future value. That's what you want to find. Present value 0. Okay, so you can, and then you can get the answer. Okay, so I'll leave you to that. Okay. So that's the end of this module. Here you can find more SOA problem. I would encourage you to try this problem because they are different, and then they give you what kind of problems you will see in the exam. So please try this problem and let me know if you have any questions.